This is number 37 on page 314, and this is a quadratic equation. It's in standard form. I have a quadratic z squared, I have a linear z, and I have a constant. And you'll notice that the coefficients, these two, are in complex form. They're imaginary. They have real and imaginary parts in complex form, and the coefficient to the squared term is just 1. And quadratic formula should still work, and does still work on an equation like this. So our A, when this is in standard form, is a positive 1. B is a negative 3 plus 2i. And I'm just going to simplify that to just distribute that negative to make this negative 3 minus 2i. It might be a little easier to work with. And then C is a 1 plus 3i. So substituting everything into the quadratic formula, we've got the variable z. Z equals the opposite of b. So the opposite of negative 3 minus 2i plus or minus the square root of b squared. So I'm putting b squared minus 4 times a, which is 1, times c, which is 1 plus 3i, and this is all over 2a, so it's all over 2 times 1. So up here, this is going to be a positive 3 plus 2i, plus or minus. Now, under here, I've got to square the negative 3 minus 2i. So if I do that right up above here, I know the pattern is always the same. I get the first term squared, which is negative 3 squared, or 9, minus this product, so minus 2 times the product of those. So I'll get a 6i plus a 6i, so I'll get a plus 12i, and then plus 4i squared. Okay, but the I squared makes this a net minus of 4, a negative 4. So 9 minus 4, so let's go here. So when I square this, I get a 9 minus 4, or a 5, plus a 12i. And it's that whole thing minus 4 times 1 plus 3i. So if I just distribute that 4 to the 1 and the 3i, I get a minus 4 and a minus 12i. And again, this is all over 2 times 1, 2. Should have just written 2. Okay, so anyway, continuing on, let's simplify this over here. I've got a positive 12i and a negative 12i that cancel each other out, and I have a 5 minus 4, which is 1. So that whole thing simplifies to plus or minus the square root of 1, which is going to be a 1. So now in the numerator I have 3 plus 2i plus or minus 1 all over 2. So the 3 plus 2i stays together. I have to look at the plus path where I add 1 to this, and the minus path where I might subtract 1 from that. So the plus path is going to be 3 plus 2i plus 1. So that's 3 plus 1, or 4, plus 2i all over 2. And when I simplify that, there's a common factor of 2 in the numerator of both rational parts and here. So that will come out to be a 2 plus I. Then on the minus path, when I go 3 plus 2i minus 1, a 3 minus a 1 is a 2. So this is just 2 plus 2i all over 2, which, dividing out the 2 in the numerator and denominator, I just get 1 plus I. So the two solutions to this problem are 2 plus I and 1 plus I, both in a plus bi form. The a is 2 in this one, the b is 1. The a is 1 in this one, and the b is 1. So that is problem number 37.